Hello viewers, welcome back to our lessons on aircraft propeller. I'm your instructor, Warrant Officer Class 1, Hanford Richard. On our previous lesson, we learned about principles concerning aircraft propellers. Today, I'll be taking you through forces acting on the propeller. As aircraft works, it encounters so many forces or it comes under so many forces. So today, I'll take you through some of the forces that the propeller encounters. The first one I'll touch on is the centrifugal force, followed by thrust bending force, torque bending force, aerodynamic twisting moments, centrifugal twisting moments, and vibrational force. So these are some of the forces that act on aircraft propeller as they work. Now, centrifugal force. The centrifugal force is a force that tries to pull the propeller blades out from the hub. You know, the propeller blade has been attached to a central hub. So when it is caused to rotate, there is this force which is called centrifugal force that tries to pull the blades out from the hub, just like you have tied a stone to a rope and you are rotating it. The stone try to flex out to move the rope from your hand. So it is the presence of centrifugal force that causes that movement, trying to pull the blade out from its hub. Now this force is serious so much that it can cause a greater stress for the propeller blade, and it is greater, multiplied by 75 times the weight of the propeller blade itself. That is how stressful the propeller blade undergoes. So on the picture, you see two propeller blades rotating and it encounters centrifugal force which tries to pull the blade out from that central point or the hub. This is another picture that shows a four-blade propeller. As it is in operation, the propeller intends try to move out or tries to move out from the hub. It is as a result of centrifugal force. Our next force that we will talk about is the thrust bending force. Thrust bending force because as a result of thrust. Previously, we learned about how thrust is produced by the propeller. Now, if the aircraft is supposed to move forward, now the thrust is created at the rear of the propeller. So, by Newton's third law of motion, it causes the aircraft to move forward. Now, because the aircraft is supposed to move forward and the thrust is generated at the rear, there's this load or this lift we call thrust load. The thrust load occurs behind. Once it occurs behind, it tries to move the propeller blade forward, especially at the tip, because it is at the tip that is lighter. So it is the tip that suffers from this thrust load. So as you generate thrust behind the propeller blade, the thrust load affects the tip such that it flexes the tip to move forward. In the same way, when the lift is generated in front of the propeller blade, as in you reversing or causing a reversible thrust, causing the aircraft to move backwards, the thrust load occurs in front that will also try to move the propeller tip back. It will try to move the propeller tip back because it's the tip that is lighter. So thrust bending force is as a result of propeller generating a thrust that will cause the tip to be flexed, either forward or back. So thrust bending force here attempts to bend the propeller blade forward at the tip. Here is forward because the thrust is generated to move the aircraft forward. Now, if the thrust is generated in such a way that the aircraft is to move rearwards or reverse, then it is the tip that will bend backwards instead of forward. This occurs because the lift towards the tip of the blade flexes the thin blade section forward or backwards. Now, the thrust bending force opposes the centrifugal force to a certain degree. Just as when centrifugal force tries to pull the propeller blades out from the hub, thrust bending force also intends to try to flex the thin tip forward or back. By so doing, it tries to encounter or counter-react the centrifugal force. Viewers, I'll end here and we'll continue our lesson on forces acting on propeller the next time I'll meet you. Thank you and have a wonderful day.